Okay, sorry about the noise again. Now I am spinning with my 1/3 horsepower Marathon brand 3-phase AC motor set up as a rotoverter with a 4 US run cap over there, plugged directly to the grid, and I'm spinning my DRMG dual rotor motor generator. And right now in AC on the generator coils at 1800 RPM, 53 volts, and it's taking 100 milliamps and 120 volts input. Now I'm looking at the generator coils. You know, there's the generator coils over here and then the drive coils over here, the motor coils over here. So I'm going to short out the motor coils right now while I'm taking power from the generator coils. Or at least I'm looking at voltage from the generator coils. So let's watch what happens. Now I'm shorting out all those 8 motor coils that are in series. For some reason the generator coils now only produce 40.8 volts and the draw has gone from 110 milliamps to 230 milliamps at 120 volts. Okay, so hold on, I'm going to do the opposite now. I'm going to look at what the motor coils make in voltage, and then I'm going to short out the generator coils. Right now I'm looking at what the generator coils make in voltage and shorted out the motor coils. So just 1 minute. Okay, the motor coils working as generator coils make 16.5 volts. And of course it's still 100 milliamps. Now what's interesting here short out the generator coils, just shorten them out right now. Draw stays the same, and voltage drops down to 13. Here's what the motor coils make in voltage, and now I short out the generator coils and it goes down to 13. I expected a lot more things happening when I shorted this out. I'm going to check to make sure these are still making voltage. Just 1 minute. Okay, yes, they are. Here's the generator coils, the 2 gray wires, and they're connected to this meter, and it says 53 volts. So they're making voltage. I have a feeling not much amps. So let's look at the amps. I'll put this in 20 amps AC, and it's not that bad of amps. They're making 170 milliamps shorted out, the generator coils over here. There's 8 of them. They're higher impedance than the motor coils. So we're looking at 170 milliamps and 53 volt amps, not watts, because I don't have a resistive load on them. Let's see what happens. Also, it's still the same input in. Okay, now I'm going to hook the motor coil. I'm not going to separate the generator coils from the motor coils. I'm going to wire them in series so it's just like one big generator coil in between these two rotors. And my previous video where I tried it as a motor, that's what I was doing. So one moment. Okay, with the motor coils and generator coils in series, so it's just like one coil. They are not separated. I'm getting 67 volts AC, which is what you'd expect, because I was getting 53 and 16, so combined it's 67 volts AC. And it's still 100 milliamps. Now, I'm going to short, see what the amperage is being made, maximum amps, because I'm shorting them out with an ammeter, call it crowbarring. So let's see what happens. As soon as I press this in, I'm going to short out the generator coils and the motor coils in series. Ready? Here we go. 180 milliamps with them combined. I have quite a bit of air gap. I'm sure if I reduce the air gap, I could get more than 180. But it spins easy at this air gap, so that's what it is. Okay, when I shorted this all out, the draw only went up from 100 milliamps to 110 milliamps. That's all it went up. That's pretty good. So, let's see, what else can I do? Take the shaft, I'm kind of grabbing the shaft now with my fingers. It's going up. You can hear it motor lugging as I grab the shaft. So it's got some pretty good excess power. It doesn't want to stall, that's for sure, very much. I'm going to take this board and rub it on it. Okay, just a minute. Okay, I think I'll do one more test about the motor coils being shorted out. But right now, just with the generator coils and motor coils both working as one coil in between these two rotors, shorted out, it's 180 milliamps. The draw goes up from 100 to 110, maybe 105 because it's flashing. So, what I'm going to do now is this wire. Okay, wait 1 minute. Okay, this is very interesting. I have the generator coils free. They're doing nothing. I'm shorting out the motor coils, which have much lower impedance. And look, I'm getting in amperage, shorting them out, 1.27 amps. And the draw goes up 0.2 230 milliamps. Interesting, huh? The motor coils are only 15 millimeters in length, while the generator coils are 30 millimeters in length. And these have higher impedance too than the motor coils. So that's interesting how all that amperage is made, and it also causes lens breaking, so it has higher draw. So this is all some pretty good numbers. Here's the other one. Now this one, I have these little coils made with sewing machine bobbins, the ferrite core and Litz wire coils, and the magnets are, you know, two rectangular. And you see that, you know, they're stuck together and then they're bucking right in the middle, and that bucking makes a stronger field and a longer field come out right there at that where they meet. And I was getting 1 amp out of just one of these coils. So I don't know what all that means. But now, interesting, when I run these in series, I don't get this lens breaking effect. Here. Okay, I'm going to pause for a bit. I'm going to try to offset the rotors a little bit, see what happens. So hold on. Okay, it's quiet now. So, just so you know, I have 8 magnets in each rotor. It used to be 16. I popped out every other magnet, and straight across is empty, but there's one here and one here, so there's this triangular zigzag effect. I explained that the last video. And so that's the way it is now. So I'm gonna move this, one of these rotors, so there's an offset, and see what happens. Okay, hold on. Okay, so here's the new offset. Kind of crazy one, but I have the motor coil magnet. The edge on the right is lined up, centered on the generator magnet. So looks like that. Here's one here and one here. This one used to be like right here in the middle of these two, you know. So I have it way over like that. I have no idea how it's gonna go, but let's see. Okay. The amperage now coming out of the motor coils, you know, the ones on this side, the 8 motor coils here in series, I'm getting 1.43 amps. That's more than before, I believe. But look, now the draw is all the way up to 1 amp. So this is like 120 watts. Oh, duh. I had the start cap on. Duh. Okay, I took the start cap off. Now the draw is 0.3. It was 0.23 before with motor coils shorted out. So it's actually making more. It's actually making more power input, but making more output. But there is still quite a bit of lens effect. So I'm going to change the offset again. Okay, now I have the magnets here straight across to the magnet here. So it's just magnets, straight across, no offset. This will be interesting. This is kind of normal. It doesn't spin as easy. It wants to latch more than when I had it kind of the triangular fashion. I can feel that. Okay, well, let's start this up. Hold on a bit. Okay, draw now, 0.37. I'm getting more amps out, 1.56. But it's actually more lens breaking. But I am getting more amps out, but that's not what I'm looking for. I'm looking at the minimum lens breaking. So I'm going to change it again. You know, I'm just looking at the motor coil because the generator coils don't really do much as far as lens breaking. So I want to see the lens breaking happening and then see if the offset improves things. Okay, hold on a sec. Okay, now, here's the motor coil rotor, here's the generator coil rotor. The motor coil magnet has its edge lined up with the edge of this one. That's going to be the new test. And it's going this way, so the generator coil is trailing. Okay, hold on a sec. Okay, here we go. Good amps are being made. I took off the run cap. Now that's better. 0.23. But I believe the original triangular way is going to be the best. Because that was 0.23, this is 0.26. Okay, now I'm back to the original. This is, let's see if you can see the rotor magnets here. There's a rotor magnet. Oh, let's see. Anyways, this is triangular again. This magnet on the motor coil, this magnet on the generator coil is lined up straight across to an empty space. And then there's one coil magnet here, one magnet here, one magnet in the middle. So this is the triangular thing again. It goes like this. This is what I originally did. Somebody stole my car. So, okay, hold on 1 second. Okay, it's making 1.26 amps. The motor coils are. And the draw went up to 0.22. So, I would say this is a superior way to offset these rotors. Now, it's not making AC right now because I don't have the same polarity of the magnet going this way as here, so that it will this end of the coil, then ring this end of the coil the same polarity, and that'll cause AC, because it swings and wings like that. But I have north facing this way and south facing this way, so if you look at a scope, it's not going to be AC, it's going to be a succession of sine waves, positive sine waves probably. And there's probably a collapsing field in between too that goes down negative, but I haven't looked at a scope yet. So I'm going to do one last test. I'm going to hook these again in series and see what happens. Okay, back to the original. I'm making 66. I don't like that number there, 66.7. And it's got 100 milliamps input, 120 volts, 4 UF1 caps, and they're in series now. The motor coil and the generator coils are in series. Now, let's short out the whole schmeal of motor coils and generator coils in series. Let's just short all that out with this thing. With the ammeter in AC 20 amps. Here we go. So that's weird. So what I get is 170 milliamps is all. Well, I get a lot more amps if I just do the motor coils alone, but when you combine them with the generator coils, you get this much amperage, and actually draw just barely goes up as far as lens breaking goes. So that's not too bad. And I guess I'll call it a video. I actually got a lot further today than I thought I would. And that's about it. Okay, thanks for watching.